Continuing on in Unit 6, Inequalities. Today we're going to be talking about Section 6.3, Compound Inequalities. Compound inequalities are two or more inequalities connected by an or an and. Okay, so we're going to start off with the or statements. The or statements, in order to be a solution to the inequality, the answer must satisfy either one of the inequalities. Doesn't matter which one, it has to satisfy one of them. Okay, so typically an or statement is written like this: x plus 3 is less than 4, or x minus 7 is greater than 9. Okay, so when you graph the solution, what it would be is the two separate graphs put together. Typically, what you're going to see is you're going to see a graph that looks like this. So we're going to have our three values. You'll have something like this that will go left. You'll have something like this that will go to the right. Okay, so typically an or statement is going to give you two wings, I guess would be a good way to say it. You're going to have something to the left, something to the right. Because an or statement, you get everything from both graphs. Okay, everything from both graphs. Okay, that's what we get to keep. So everything from both graphs. So the next one, though, is we still have our or and we still have our and, but this time we're going to talk about the and statement now. In order to be a solution to an and inequality, a compound inequality with the answer must satisfy both inequalities, meaning that you have to make both inequalities true to be a solution to that compound inequality. Typically, it is written like this, which is read as -5 is less than x plus 3, and x plus 3 is less than or equal to 6. But it can also be written like this: x plus 3 is less than 7, and x minus 1 is greater than 4. Now, you'll notice the difference there. On the first one, the x plus 3 goes to both items, where on the second one, we have a different part that has the x in it and a different number, but an and can be written either way. Now, when you graph, the solution would be the part of the graph that is shared by both. In other words, we say it's the part of the graph that overlaps from both graphs, from both inequalities. So typically what happens on an and compound inequality is you're going to get a graph that looks like this. It might be an open or a closed, and then you're going to have shading in between. Okay, that will be the part that is overlapping. Okay, so that's what they look like. All right, so how do we solve them then? To solve them is not much different than what we've been doing. The difference comes at the very end when we get ready to graph. So the steps are you solve each inequality using the steps we have learned, and we practice by solving inequalities so far. Second, we look at it as if it is an and or an or statement, so that when you graph, you know if it is only the overlap or is it all of the graphs from both. Okay, so remember, an or statement gets everything from both. An and statement only gets what's overlapping, because an or statement, remember, means that you can be either one of them. You can make either inequality true, where an and statement, you have to make both inequalities true. Okay, so here we go. Let's give it a shot. So on this first one, I'm going to start over here, and I'm going to solve this first inequality. So to solve that, I'm going to add 4. So that would get me x is less than -9, okay? And I'm actually going to go ahead and just graph that real quick. So I have -9, 0, and 9. It'd be an open circle, and it would be to the left. Then over here, I'm going to take and I'm going to divide by 4. And that would get me x is greater than or equal to 2. And if I look at that inequality, I would have -2, 0, and 2. It would be a solid circle, and I would shade to the right. So now we ask, is it an or an and statement? And this one is an or statement. So now we're going to take those two graphs and we're going to smoosh them together. You get everything from both of them. So what I'm going to do is I'm going to list my numbers out. You are welcome to do more than 3 if you want, but you don't have to. So what I did is the critical value from the one on the right, the critical value from the one on the left. So what I'm going to do is I'm going to take the graph from the left, bring it down. I'm going to take the graph from the right, bring it down, and that is my solution set. Okay? So that's how we do an OR statement. All right, let's try another one. So again, I'm going to start off on this left one, and I'm going to solve it. So I'm going to minus 5. So that's going to give me negative 9x is less than or equal to negative 63. I'm now going to divide that by a negative 9. So x is greater than or equal to 7. Remember, when you divide both sides by that negative, that's what caused this to flip. Okay, so now I'm just going to graph that. So I come down here. I go negative 7, 0, 7. It would be a closed circle, and I would shade it to the right. Okay, so now we know that's an OR statement. So now I'm going to come down here, and I'm going to solve this one. So I'm going to minus 7. So now I get 10x is less than negative 10. I'm going to divide that by 10, and I get x is less than negative 1. So that graph, I would have negative 1, 0, 1. It would be an open circle, and it would shade to the left. So now we've already said it's an OR statement. So now I get both graphs put together. Okay, so I'm going to take both of these graphs. I've got a negative 1, I've got a 0, and a positive 7. So I'm going to take and do the positive 7. It'd be a closed circle, shade to the right. I'm going to do an open circle at negative 1, shade to the left. And that is our solution to that OR statement. Okay, let's try one more. So we're going to start here. I'm going to minus my 3 from both sides. So I get 4n is greater than 8. I'm going to divide that by 4. So n is greater than 2. I then come down here to the graph. I'm going to go negative 2, 0, 2, open circle, shade it to the right. Then I come over here. I'm going to minus 5 from both. So now we have 8n is less than or equal to negative 48. I'm going to divide that by 8. So n is less than or equal to negative 6. So I'm going to come in here, and I'm going to go negative 6, 0, and 6. I'm going to make that a closed-in circle, and I'm going to shade it to the left. It's an OR statement, okay? It's an OR statement. So I'm going to come in here now, and I'm going to draw my graph. And remember, this graph will be everything from both of them. So negative 6, 0, and 2. I'm going to close it at negative 6, and I'm going to shade to the left. I'm going to open the circle at 2, and I'm going to shade to the right. And that is how we do OR statements. All right, now let's try an AND statement. So when we look at this problem, remember this is an AND statement. So I'm going to start off. Now, it looks kind of weird, but whatever we do to the middle, we do to the both outsides. So what I'm going to do is I'm going to add 8 to all of them. So now that gives me negative 2 is greater than or equal to x is greater than or equal to negative 4. Okay? Now, if you want, you could graph these separately. So if you graph this first one, so this would be negative 2, 0, 2. It'd be a closed circle at negative 2. And it says negative 2 is greater than x, so x must be less than negative 2. The second one here would be negative 4, 0, and 4. It says x is greater than or equal to negative 4, so it'd be a closed circle, and I would shade to the right. Now, remember, this is an AND statement. So we only get the part of the graph that is overlapping. So if I line those graphs up, remember, negative 2 would be like right here, and negative 4 would be like way over there. Okay? So if I line these up, here's what it would look like. Now, you'll notice on this final answer, I shifted the 0 to the right because Both of my critical values are negative. So what I'm going to do now is I'm going to come over here to -4. I'm going to put a solid dot. I'm going to go to -2, put a solid dot. And the part that is overlapping is this part in the middle. And there is our solution to that. Okay, let's try another one. This one you'll notice is written out with the and. So the first thing I'm going to do is I'm going to -3. Then I'm going to take and divide by 2. And then over here, I'm going to minus the 16. And that's going to give me -3x is greater than or equal to -24. Then I'm going to divide by -3, which remember, that makes that inequality flip, right? So as I bring that down, I'm going to flip that inequality. So now when I go to graph it, if you read this, it says x is greater than 3, but it's less than or equal to 8. So I'm going to put 0 on the left side, 3, 8. It would be closed at 8. It would be open at 3, and it would be the space in the middle. All right, last one. Here we go. So remember, whatever I do to the middle, I get to both sides. So I'm going to -5 from each of those. So that would get us -24 is less than or equal to 8x, which is less than 72. I'm going to take all those and I'm going to divide them by 8. So that's going to get me -3 is less than or equal to x less than 9. Remember, this is an and statement. So I only get to keep what is overlapping. So I have -3, 0, and 9. It's an open circle here. It's a closed circle here. And the part that would overlap would be the middle. And that is how we do compound inequalities.